Much for joining. We have an exciting conversation today. With me is Rick Francosa, former Gartner analyst, and also so many more things over the course of his career. As Joe said, I'm the director of product marketing here at Copia, and one of the focuses of our conversation today will be the State of Industrial DevOps Workforce Report. We recently published this report using some of our own survey data that surveyed 200 executives across the United States, many of them, 58%, in fact, from $1 billion and over in revenue organizations, and 42% of the 200 being with C-suite titles. So very high-level executives at large organizations capturing their views on workforce and industrial DevOps. So we're going to reference some of that data, and in this report, we also pulled a lot of public data from Chamber of Commerce, from the St. Louis Fed, and many other resources. So that'll help be a foundation of some of the questions that I'll be asking Rick and some of the data points that I'll pull in as we discuss. And without further ado, I'm going to hand it over to Rick for a deeper introduction. Rick, thank you so much for joining today.
Oh, I'm glad to be here, Jerry. It's yes. Jerry mentioned I was a Gartner analyst. I did that for about 10 years, best part of my career, I would tell you. Really going back, I started out in manufacturing, working for a large aerospace and defense company, moved into the computer software world, and which was the majority of my career, mostly supporting software for manufacturers, things like computer-aided process planning, MES, PLM, etc. I retired last year, but Jerry offered me this opportunity to kind of talk a little bit about the whole topic of automation, where it's come from and where it's going. And so, Jerry, why don't we kick it off?
All right. Yeah, and I asked you, Rick, because we've had so many great automation conversations over the years, going through those MES Magic Quadrant cycles that we talked about before we came on, and just your wealth of experience covering decades of automation. And this report, I've really dug into the last 5 decades of automation to understand the technologies that came in and influenced the evolution of automation, the processes that came in like lean manufacturing and others to influence how people were working within the organization. And then last, but certainly in the wrong order because it's first, workers and how the workforce experienced these changes and went through the years of evolution. So the first question I had for you was really looking for your context. A lot of things have changed in the last several decades, and I'd love to hear you talk through what you think were the biggest changes in automation and why.
Yeah, okay. Really to set the stage, and I actually look back, and it's been a little tiny bit more than 50 years since I started in manufacturing. So I started out, actually had a co-op job at Pratt & Whitney Aircraft in the early 70s as a parts expediter, because the way that manufacturing was done in those days, they had a mainframe computer. It would spit out a schedule. And as far as instructions for the people on the shop floor, the computer had a 40-character limit to how you could describe an operation being done on the plant floor. And so it was the job of the expediter not only to keep things moving, but also to make sure that all the other information the folks in the shop needed was available, obviously in paper form. You start to look at the introduction of PLCs in the 1970s, the introduction of what was then called MRP, manufacturing resource planning. And you started to see where things were going to move. In those days, getting instructions to a machine tool involved things like paper tape, being fed into a machine. As a matter of fact, even interacting with computers involved, if it was a time-sharing system, you were feeding things in by cards or paper tape. Um, it was uh, it was interesting, but it was exciting because we were starting to see how things could improve. You know, you moved to the 80s, you had mini computers, you had next generation computer languages, computer-aided design, computer-aided manufacturing. You know, in the 90s, you started to see networking, not just networking between mainframes, but networking between pieces of equipment. And a lot of companies were trying to figure out ways to provide connectivity between, you know, what was going on the IT side and what was going on within the plant. Typically, those things were completely disconnected. The 90s also brought new software technologies because you did have some level of automation technology within the factories, and you had business technology for managing things like scheduling and planning. But there was a gap in the middle, and that gap was identified by a number of organizations, in particular AMR Research, which is now the Gartner Supply Chain Group, and they coined a term called MES, Manufacturing Execution Systems, for that gap. And so as you move from the 90s into the 90s, the mid 90s, you started to see some standards develop. You saw, you know, the Purdue Enterprise Reference Architecture slash ISA 95, where you now had definitions of what belonged in the plant and what belonged in that middle layer, that what they layer 3, and what belonged in the office environment, and how you would communicate between them. And you know, ironically, you know, even as you moved into the next century and ERP and MES and PLM grew and became more prevalent and more complex, you still had bespoke environments where, you know, each of those 3-letter acronyms, you were seeing, you know, highly customized solutions that were a nightmare for change management. And, you know, 2010, people said, well, let's throw it all away. Let's focus on industrial IoT and big data and analytics, and move into, you know, the current decade. And it's, well, you got to go beyond just analytics. You got to go move into artificial intelligence and DevOps and those sorts of things. I find it really sort of interesting that, you know, even as all of these things have bubbled up from, you know, those humble beginnings, you still have, in my case, the clients that I talk to and the vendors that I talk to would still be talking about ISA 95, and that, you know, your MES system had to be influenced and designed and built on top of this standard that is now 30 years old. So I guess the more things change, the more they stay the same.
Totally, Rick. And I love that brief but thorough walkthrough of the last couple decades.
Yeah.
And it's so interesting to think about standards because I still hear them come up in conversations on a weekly basis. The Purdue model,
Yeah.
how the organization is structured, how OT is firewalled away from the internet, and like personally, just things that Copia looks at on a regular basis. We see this shadow OT develop because while networking is laid out a certain way, there's practical intersections of technology and people need to use them. So they find workarounds. And I think later in the discussion, we'll touch on this a little, but that raises your exposure from a cybersecurity stance.
Sure.
So yeah, these standards just don't really fit in today the way that they used to. So this is leading me to my next question, bouncing off that last point you had, thinking about, I mean, my assumption based on all the data I've gone through is that industrial production has stalled out. Despite all the technologies, all of the promise that we have right now, when I looked through the data from the St. Louis Fred and that government industrial production index. I saw it shoot up in the 90s, and that's when lean manufacturing, Wintel, and workers, that people, process, and technology connection seemed to work really well. But looking especially at the last decade, it's really been flat. So I wanted to get your take based on everything we just talked through on one, do you think, from your perspective in conversations of the last several years, industrial production has stalled out? And if so, what are some of the contributing factors that you've seen?
Sure, and there's a number of factors. I'm just going to focus on a couple. One is um, the fragmented adoption of technology. And it's easy to blame software vendors. It's easy to blame workers, but I think the issue is that in general, technology companies are driven by the need to grow and to provide stockholder value and continue to add revenue and continue to take over more space. So you see things like, really forced to being innovative and expanding, inflated expectations. The vendor community will hop on to whatever that new thing is. I saw vendors that would, when people started talking about industrial IoT, the whatever connectivity they had that they were providing to the market, they rebranded as industrial IoT. When we moved forward and, Gartner started talking about composable solutions, well, suddenly everyone was composable, and certainly about the time last April, as I was finishing up my career, everyone was adding AI to their marketing descriptions. And so the solutions are built on the same platforms they always were, because that platform change is very expensive. Hauling around all those existing customers and trying to get them to move forward, it's a very difficult task. And so I think that a big part of this is that companies will invest in pilots for IoT, for DevOps, for AI, for whatever else, and they may have a little bit of success, but it doesn't scale. And so it becomes almost wasted effort. And so I think that there is an issue of the technology changes are coming fast and furious, and the process change and the upskilling of people is not keeping up.
Yeah, and that's so many different pieces to unpack. And I want to start with the people part, because that's one of the biggest things. We've been talking about workforce everywhere and getting people on board. And you mentioned a few, like, I don't want to say buzzwords, but like really important words that keep coming up. And I think have probably been coming up since you entered the field. That's legacy systems, customization, fragmentation. These are things that are ever present that people seem to be trying to solve for. And I think this leads me into my next question, thinking about everything we've talked through so far. And are there lessons to be learned from the evolution of automation? How maybe one part of our space has dealt with legacy, or maybe a example of a leader lighthouse type organization you've talked to. And I'm also thinking about things we've seen in IT, like since I came to Copia and really dug into the DevOps space. It's incredible to me what DevOps did for IT. And if you haven't noticed already, based on this report where I covered 50 years of automation, I like to dig deep. So I dug really deep on DevOps and found that manufacturing and IT have been borrowing systems from one another and adapting them for decades. And this is just another example of that. And DevOps came from theories from Eli Goldratt, the theory of constraints coming in, initiating agile methodologies, lean, Lean was a huge influencer on DevOps, and now today, looking at industrial DevOps to help evolve the OT space. So that's a lot of words for what is probably a simpler question. What your thoughts are is what I'm looking for, Rick, on this evolution of automation, the changes that DevOps brought to IT, and anything you think the audience could get as takeaways from a best practice or something to learn there.
Well, I think, and it's really interesting. One of the things that I find really paradoxical about that is that when Lean came to be, and you mentioned Goldratt, one of the main tenets of Lean by the early adopters was it's not technology. It should not involve technology. It is a process of continuous improvement. And in those days, on my side, I was working for software companies at that point in time, and we couldn't break through because, the Lean infrastructure was basically saying, technology is the wrong way to go. And it's only recently that is sort of flipped. And honestly, I hadn't thought about it the way you mentioned it there, but DevOps really did learn from Lean as opposed to the technology that was available at the same time that Lean was coming up. And I think when you look at this, the way that DevOps is constructed and the way that IT works, and especially as you move out, out onto the fringes of the, people who believe, move fast and break things, that is an anathema to production. If you're in manufacturing production, your job is to make parts and get product out the door. The last thing you want to do is break something. And so, and this is not new. Gartner had a concept that they talked about called bimodal. This goes back probably 5 years, maybe longer. And the idea behind it is that innovation is what they call mode one. And that's where you fail fast, you try new things, you move fast and break things. And that allows you to very rapidly bench test new ideas, new technologies, new processes. And mode two is, production worthy, production ready, low risk. And so the trick is, when do you take the mode one and roll it into the mode two? And this is not a technology question. This is a process question. We talk all the time about, people, process, and technology, or as Lockheed Martin said, they did a joint presentation with me years back, people, process, data, and technology. The issue behind people, process, and technology, it's not put together that way because that's alphabetical. It's because that's the order of importance. People first, process modification, process change, process evolution second, and then applying technology to that third.
And that's such a great point, right? And something I tried to hammer home in this report, the workforce, people coming first, process, also digging deep in history, thinking back to Deming, the founder of so many things that we just know today in terms of quality, process, and automation. And one of my favorite quotes from him was, "No automation is going to replace a good process. You get the process in place, and then you test it, and then you test it again, and then you see if you can improve it, and then maybe you bring in that layer of automation, but you have to go through those continuous improvement cycles, working with people, like the actual people involved in the process, because a huge part of getting that process to work is having the people drive the process forward, and then bringing in that technology. And my next question, I was going to ask you the biggest hurdles we see in industrial automation, especially around legacy systems. And I think it's really tied to this respect for people and process first. And I wanted to hear your thoughts on those hurdles, especially related to legacy, thinking about the mode 1 and mode 2 that you're talking about, because I've seen in my research so many organizations that are really good with mode 1, but when it comes to moving beyond that, there's so much hesitation, going back to what you were talking about, also about breaking something.
Yeah.
Our earlier report, State of Industrial DevOps, the first report we did, tracked downtime, and it was 4.2 million per hour. Again, from feedback from high-level executives, large organizations, thinking about not just the line going down, but the cascading impact that hits their supply chain, hits their customers, maybe hits conversations with lawyers and insurance because there was a safety issue. Like,
Yeah.
very expansive impact. So again, I probably overset this up for you, but I'd love to hear your reaction for those hurdles and trying to think about where to
Yeah.
overcome
Yeah.
them.
We talked about this a lot. There was a research note, digital manufacturing requires a new look at old systems. And that came from being approached by both vendors and end user customers who were saying, we have this old system that we'd like to replace. But when we go to the CFO, all of the benefit we got from putting in, for example, our first MES system, we weren't going to get those benefits again in addition, because we already had it, and it was a very tough hill to climb. And I think that's a big piece of this too, is not just from the standpoint of, oh, we've got all these old systems, how do we move forward? Is how do you justify moving forward? And that justification, I think, is one of the most important things. And you already mentioned one of the pieces of justification, and that's look at cybersecurity risks. Because there are situations where you just can't get past that cybersecurity. Certainly, I recall customers who are still running really, really old Windows servers releases because the product didn't work on anything newer than that. There was a client of mine, both before and after I joined Gartner. They had a homegrown system that was actually really, really sophisticated, but on a really old platform, and they couldn't replace it. And eventually, they got IT to step up and rehost it. And you'll have those situations. But also look at technology risks. I mentioned to you the other day about an aerospace company that was a client that wound up buying a new system, because they were tired of buying parts for their digital equipment company VAX machine on eBay. And when they got to the point where it was almost impossible to find replacement parts on eBay, they figured that, well, maybe it was time to replace the system. But I think the other way you can justify it, because certainly those first two are they're kind of slam dunks if true. No company is going to balk at spending money if there's a cybersecurity risk, or balk at spending money if the technology is just not working anymore. But the third piece is determine what a new system can do that's just not possible with the old. And so you can compare, let's say, an MES system that you put in 15 years ago with what's available now. There are certainly going to be things, whether it's connectivity, whether it's the availability of more use of the internet, more use of things like AI, or even at a very basic level, that you're not going to be able to do with the existing system. Those are the sort of things you want to look into when trying to move past legacy systems. And sometimes it's really tough. Sometimes you wind up having to kind of partition one from another, and kind of do it that way. In aerospace and defense, it was always relatively easy because typically when you got a new project funded by the Defense Department, there would be uh, um, enhancements. What's the word I'm looking for? There'd be incentives to upgrade your technology as part of that project. But that's not available in every industry.
No, definitely not. And there are, I mean, that's a great point that I almost pulled into the same report, the incentives that are available, because I think some organizations overlook those, but state to state.
Right.
If anybody on the call is interested in those, I did some research and you're welcome to reach out. But going back to your points, Rick, I really appreciated when thinking about getting over these hurdles. You mentioned these key points of cybersecurity, the actual technology, and what the technology can do for you versus the old system. I think a lot of people get tied up in that sunk
Yes.
cost fallacy. I know I worked at organizations. I told you I worked not that long ago at an organization where all of our internal programs were in DOS. And I helped with our migration out of those DOS programs. And the reason that we migrated out of them was because the one person that wrote them and could manage them and keep them up was retiring.
Yeah.
And nobody could possibly take that over.
Yeah.
So there's so many risks with maintaining the same technology, even if the status quo is working. And when I hear you talk about the advantage of the new system, that immediately made me think of the competitive advantage, both
Right.
in your space to be able to produce more efficiently, to be able to communicate with customers more efficiently, like whatever particular technology it is and advantage it brings to what you're trying to accomplish, that can be huge. And all of this drives me back to the first part of our equation, thinking about people. And
Yeah.
when I hear those three things, I think about the human cost of if you're using an old technology and there is cyber risk, there is a person there who is going to take the brunt of that cyber risk.
Mhm.
And if there there is a breach, it falls on somebody or somebody's, and then how is that going to leave them? Are they going to be punished in some way by the organization? Are they going to be laid off? Like, or are they going to be responsible for fixing the problem, but under-resourced, so you're stressing them out to a point where they might leave? And then thinking about old technologies and having people work in them. If you bring somebody in, like my example, working in DOS programs, that person's going to walk out the door and keep
Yeah.
going because they're not learning something that's going to upskill them. And I think this leads into our next question. Workforce is such a central issue within manufacturing today. And whether it's just like, I can't get the workers, or there's a skills gap, or there is this knowledge transfer issue.
Mhm.
Um, I thought you had some great points when we were prepping for this. So I want to hand it off to you
Yeah.
wherever you want to take it, thinking about workforce.
Sure. Sure. And I will point out when I joined the workforce in the early 1970s, the hottest topic in engineering was how do we capture the knowledge of our aging workforce? So this is
In the
by no,
70s,
yes, this is by no means a new problem. Um, so it's been a problem with every generation. I mean, it's no different than, these kids and their loud music, right? So there's a number of ways to look at this. One is um, certainly the idea of using large language models and AI to, kind of build best practices out of historical knowledge where it exists. That's something that when I started to talk to vendors that were looking at things like ChatGPT and large language models. That was what they almost all of them honed in on is best practices. It's, and in some cases, if it was IT, it was coding standards, looking at how code is written and then being able to say, if you're doing this sort of code, this is kind of the direction you want to go in, and these are the things you want to keep away from. But also things like some of the interesting new apprenticeship programs that have come up, and a couple of examples that are pretty well known. But just around the corner from me at GE Appliances in Louisville, there was they put a program together where they would bring in high school students as apprentices, to work, afternoons or evenings or weekends, and they would pay them better than they would get at McDonald's, but also teach them manufacturing skills, but more importantly, get them excited about manufacturing. Because I think there is some idea that you work in manufacturing when you're not smart enough to do something else, or you can't make it as a internet influencer, or as an entrepreneur or whatever else. And they've been very successful. They've used it and transferred it to other divisions. And we've also seen the same thing. Your former employer, Rockwell Automation, did a thing with veterans, veterans who had some experience in electronics, and they would bring them in and train them as OT techs for maintaining machine controls and PLCs, et cetera. And so it's really, that's a big part of it. But the other part of it is just making sure that that knowledge transfer is easy, and that you're able to continually upskill your people, because you're definitely in a situation now, as things evolve, where more and more of the work, especially the non-value added work, is going to be taken over by automation, and that having the capability of taking people, upskilling them to take on higher level work, but also to be able to maintain the automation systems, I think that's really key.
So many great points, and I love that you bring up apprenticeship. That's something that's near and dear to my heart. I love that program at Rockwell, and one of my friends works in a nonprofit, and I was connecting him to help feed. He worked at a nonprofit and is a veteran, so I was working with him to help feed more people into it. Just such a great program, taking advantage of the workforce that exists, has interest to be a part of manufacturing. And I love your point about creating that inspiration to join the manufacturing workforce. One of the things I highlight in this report is that there's so much cross-industry competition. The Chamber of Commerce, there's a report I reference in here, showed the amount of open jobs cross-industry and highlighted that there will be competition because ever since COVID, the advantages of remote work, the shortage of workers, and the desire to have different advantages. I've seen Wendy's, like you mentioned McDonald's, I've seen Wendy's with signs in the windows where they're offering paid vacation, a stipend for education, 401k, these things that were never there before, because the cross-industry competition for the workforce available is fierce. And where I'm taking this is back to knowledge transfer and thinking about attracting in workforce, and what are some ways that knowledge transfer can come in. And I love that you highlighted using AI in a focused, responsible way to help your organization, not just throwing, like, I've heard of organizations just giving all their leaders an AI goal. You need to have 2 AI goals, and that's that, or you get fired. but like no parameters around it. Do we want to generate business value? Do we want to think about how this is going to impact our resources, our people, and what we're doing? But thinking about, and I love that you mentioned code because that's where I wanted to take it, but knowledge transfer within code, you have this older engineer, controls engineer that is operating all your PLCs within your organization. And that's the person who has everything in his head to know, like, that code, you don't want to mess with that code because if you do, the machine's probably going to go down. And you can
Right.
only change these particular lines of code on Wednesdays at 10 a.m. But if you have a system where all of that information can slowly be entered and everyone can collaborate, those systems exist today. And that's like the goal of industrial DevOps. It can help modernize that space. Also, when you're thinking about legacy systems, unify the code base and bring consistency, and adding that kind of co-pilot layer. It can also help somebody new that's coming in, and maybe the controls engineer at your organization has been there forever and is a little like an industry analyst and curmudgeon-y sometimes. I've heard you say self-proclaimed we're the curmudgeons.
Yes.
But that person might not want to answer a million questions from someone new. And if you have that co-pilot that can help interpret code, document code, just move them along a little faster, then they can learn and bring more advanced questions into the fold. And also maybe bring that older controls engineer that was a little set in their ways into this modern approach to things. Excuse me. So I think that was my next question for you, Rick. And not just like specific to industrial DevOps, but in your automation view,
Yeah.
have you seen technologies that have that kind of unifying effect? Are there certain cultures that embrace it and enable it more, thinking back to our equation of people, process, and technology?
Yeah. I think the whole cultural resistance thing it's a real tough problem. Um, there's a term I learned recently, psychological reactance, which is the tendency to rebel against perceived threats to your freedom or autonomy. And it's one of those things where, seeing it firsthand, and going back in the mid 80s, I was responsible as one of a programming team for a generative process planning system. So basically, we would build a logic model and we would feed in the geometry of the part, and it would create the instructions for making the part. And we did it originally for cylindrical parts because that's a real easy, you can look at cylindrical parts in 2 dimensions, right? It's got a diameter and it's got a length. And so we thought, well, what else could we do next? Where could we use this program again? And somebody said, well, what about gear manufacturing? And so we went to the head planner in the gear department and said, sir, we would like you to tell us everything you know about doing process planning for gears. And his eyes got narrow and he said, I'm taking that to my grave. Now, if instead we said, hey, we've got this really cool thing we're working on, do you think it might work for years? And actually, brought him into the process, might have been a totally different approach and might have been a totally different, and the flip side of that is, the first major MES implementation I was involved with, an aerospace company in Southern California. And as part of the budget, the company did this really smart thing. They put budget money in to take frontline workers offline and put them in these show and tell sessions, which are really, they're kind of like what we would now call scrum meetings. But this was way before Agile, way before all of that. And what would happen is they'd bring them in, they'd show them the screens, they'd show them the interactions, and how the system works, and say, what do you think? And they would get responses like, you know, that information is not important, but where's this information? Because that's really important. My favorite one of that was they brought in a bunch of machinists and they were showing them this was a touchscreen interface, and they looked at it and they said, that won't work for us. And they said, well, why? They said, the buttons are too small. We wear these heavy work gloves. If we have to take our gloves off every time we want to interact with the system, that's not going to speed us up. That's going to slow us down. Nobody thought of that. And nobody would have thought of that from a development organization. And so the developer in about 10 minutes refactored the size of the buttons. So what do you get from that? First of all, hey, they're listening to us. Second of all, they fixed my problem. You know, and third of all, this is going to be a lot of fun to use. And so this group went back to the shop and spread the word, hey, this is really cool. As opposed to, you know, the typical approach of, here's the system you're going to use, here's the manual, here's a half an hour of training, go. And so that's, if you can knock down the resistance just by involving people, especially when it comes to things like AI, because the average person has no idea how their job will change with AI. So all they know and all they're thinking about is, I'm going to lose my job because of AI. And so, again, people, process, technology, you got to get the people on board first. You got to find out, you know, where their pain is, where their bottlenecks are, and then show them how the system will make their life easier.
God, I love that term, Rick. Psychological reactance, really digging in to think about deeply about people and the impact that it's going to have on them. Of course, when there's uncertainty, there's going to be a perceived threat. You're throwing AI at everything.
You know, I mean, in my own life, I remember when Office 365 changed something in Outlook. You know, they moved the button from the top of the screen to the bottom of the screen. The howling that was going on, you know, inside of Gartner about why did they move that button? You know, where is that button? I can't find it anymore. You know, and it's you know, to my mind, that's the curse of you know, of SaaS systems, of cloud-based systems, is that, you know, you can change everything. And it's like, hey, wait a second. I opened Word for the first time a week or so ago for the first time in a while. And there's this little Copilot icon. And I go, no, 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 no. Not doing that, not doing that. So yeah, exactly. That's we're all like that.
Totally. And I love your example of involving people. And that's why, like, I'm so passionate about industrial DevOps, that merger of development and ops, and talking to customers all the time. Some of the most successful are those that have their IT organization meeting with their OT organization interconnected with their CISO or whoever is managing security, depending on the size of the organization, so that they can catch problems. Like if you're doing an update or a security patch, let's figure out as a team a way to work around that so that it's not driving operational downtime, but instead is going to be better for everybody. That better for everybody connectivity makes such a humongous difference.
Sure. And oh, by the way, it works both ways, because, you know, the folks on the IT side could be saying, hey, this is really cool, you're going to love this. And they'll say, here's why that's not going to help. You know, because you're coming from two different worlds. You know, we had a browser-based work instruction viewer, and the developer put this just random hyperlink in the middle of it. And I said, what's that for? And they said, well, you might want to go out to the internet. Now you can do it real easy. And they were so offended when I said, that's the last thing you want to do. This thing is to provide, instructions for somebody to do their job, you know, not, just randomly go out to the internet in the middle of the day. That's a little counterproductive.
And not to like get too business speaky, but like, what is the job to be done? Really
Exactly.
understanding that in the design.
Right. Right.
Uh,
Yeah.
we've touched around it a little, but I wanted to bring it back to cybersecurity.
Sure.
It's such a huge concern, and I know we're not going to dig deep into it, but as we're talking about modernizing industrial automation, bringing connected systems in, oftentimes like tapping into the power of cloud for an organization, the
Mhm.
widening surface area of sensors, everything. Um, how can manufacturers continue to secure their environment? Do you have any guidance for that? And if so, would love to hear it. And if there's any connections into the people as well.
Yeah, this is a great one. People talk about IT/OT convergence, and um, the discussions, we used to have a lot of discussions internally, and one of the things is don't confuse convergence and alignment.
Mhm.
IT/OT alignment happened the first time there was an Ethernet port on a PLC, and that was many, many years ago. IT/OT convergence is organizational. And when you look at OT personnel and OT organizations, they have a completely different um, culture, a completely different set of drivers, a completely different focus than IT organizations. The OT organization, and we talked about this before, it's the mode 2 thing. The OT organization has one main driving goal: keep the production running. That's it. That's the list. IT is keep everything up to date, keep everything secure. The problem with cybersecurity, beyond the fact that hackers are smarter and, on and on and on, is until you have alignment between what IT has to do and what OT has to do, there are going to be these opportunities for things to go sideways. And so, one of the things, and there's some really smart people at Gartner that cover this really well. And the idea is, first of all, from an organizational perspective, the OT organization has to have the same level of importance and the same sort of hierarchical structure as the IT organization, so that the OT organization can create their standards and can enforce standards for cybersecurity, for maintenance, for, and turn it into less of a, wild, wild west sort of thing, which is what OT organizations are typically like, very much plant focused, very much department focused. And then once you do that, then it becomes a lot easier for IT and OT to be on the same page, because you have created an OT organization that is much more focused on standards, much more focused on cybersecurity, much more focused on keeping things updated. And then at some point, you begin to develop real synergy between IT and OT. And so, I think when you think about the cybersecurity hacks that happen and all of those things that happen, they're typically happening at the point of use. They're typically happening because someone took a shortcut, or, and so to try and take the IT approach and force fit it to OT, it's just not going to work. You have to build it from the ground up within the OT organization, and help them, mature what they do, help them develop standards, and help them support what they need to do. And I think a lot of the vendors, I mean, certainly The automation vendors, the Rockwells and Schneiders of the world, have put a lot of focus on this at the OT level, but it has to not only be from a technology perspective, it has to be from an organizational perspective.
I love that perspective, Rick. And I think this leads into, we talked a bit about data, and just to tee this up and building off your points there, having standards and structure within OT, not making it the same as IT, but making it purposeful in the way that OT needs it. And to your earlier point of giving space for people to test things and think about it, and I'm going to come back to the point, but one of the data points from our first annual State of Industrial DevOps report was that hot fixes are very common in 78% of the organizations that we surveyed. That is a huge percentage. And that tells me that while it would be great to have this architecture and like standards in place for OT, they're not getting any time to do that because they're firefighting, and the whole goal is to keep uptime as much as possible. And I'm also like reading from our data that if they're firefighting like this, it's likely going to continue because you do a hot fix, you have 600 different devices. It's not one, it cascades into another, and you're just kind of jumping from one to another. So I guess for our audience and just speaking at a larger level, there's a huge importance for the organization to give time to OT, and there's no silver bullet for this, but recognizing the problem and figuring out a way to work together. And this is where I'm leading into data. So those are some data points, but I really liked your take on data, Rick, for an organization. How should they be thinking about data?
First of all, the explosion of data, it's absolutely amazing. About 8-10 years ago, we made this prediction that the way we were headed, 60% of data that's produced in manufacturing would not even be looked at. In 2020, there was an MSNBC interview or CNBC interview with the CEO of, I think it was ABB Automation, and he said that in their surveys, 80% of data that is produced in manufacturing is not used. And I would say, and that was 5 years ago. So you used a great term to talk about like the amount of data and the amount of sensors out there. And I will tell you, the biggest issue with data is in some ways there's too much of it.
Mm-hmm.
And the idea that data science and AI all by themselves can turn all of this data into meaningful information, that's asking a lot. That's asking a lot. You think about where we came from, which is the guy walking through the plant and he feels a vibration in the floor, or he smells a smell and he says, shut that machine down. Because he's been there a long time and he knows what that vibration means and he knows what that smell means. And while it's difficult to turn those things into a whole bunch of data points that you could look at and hopefully come up with an answer before the machine knocks itself apart. The IoT systems that came on board in 2008 and since then, very good at the condition-based maintenance, because you can put a box around that, measure all these parameters in a machine, compare it to historical data, and if a certain case comes up, well, you've seen that before, that machine has to be shut down for maintenance. the thing about that was, as I watched that from, across the decade or so that I was an analyst, the IoT platform vendors, those use cases, those customer success stories didn't really change all that much. They were all the same thing and very valuable, very valuable. But getting to that next level where you're starting to think about not just machine, condition-based maintenance, but you're starting to think about actually running a manufacturing process, a complicated manufacturing process. There has to be obviously that the domain expertise portion of this, applying the domain expertise of your people to help the data scientists point in the right direction, or to be able to look at the results coming from AI and say, nah, I think you missed it. I don't think that's exactly right. There's a lot of benefit to be gained with all of these sensors and all of this data, and we're seeing it. I remember talking to a gentleman about, a system that would, they would cascade, kernels of wheat or milled wheat or whatever, and have this vision system looking at it and be able to shoot little blasts of air if they saw, a particle of wheat that was burnt or that was discolored, and, I remember when that was done with like, tater tots, where you're talking about, well, this one's dark brown, this one's light brown. That's easy. When we're talking about like grains of sand kind of thing, so we've done great things. We're doing even more incredible things. But I think when it gets to that next level of logic, when you're starting to talk about, can I actually run all of manufacturing, lights out, hands off, with just, sensors and AI and data sciences. We're not there yet. We may never be there. And when I hear organizations being told, each of you guys needs to do two AI projects or you're fired. What's going to come out of that is two AI projects that may or may not be valuable, that may or may not actually provide cost savings, but allow you to check the box.
Mm-hmm.
And I haven't seen anything that says, we're going to have a lot more than that. And I think that the success of things like, large language models, they're providing a path of capturing and sharing institutional knowledge. But you got to understand that these AI tools do not have intelligence. They cannot make judgments. They cannot tell right from wrong. They cannot tell true from false.
Rick, this went by so fast. I think we have about 30 seconds. We've had a wide-ranging conversation. Final thoughts from you, guidance for organizations, anyone listening?
Absolutely. And what I will say is, don't sit back thinking that the technology is going to take care of everything. You got to be in front of it. An old friend of mine had this thing that used to scroll across his computer screen. It said, if this was easy, anyone could do it. And I think you have to remember that these technologies are very powerful. 5 to 10 years from now, they will have changed the world. But you have to drive them, not be driven by them.
Totally. I love that thought for ending. Thank you so much, Rick. This has been such a pleasure for me. Great catching up and great having this conversation. And thanks to our audience as well for joining.
Thank you. Thank you very much. Had a great time, Jerry. Thanks for everything. Take care.
Bye, everybody. Thank you, Rick. Thank you, audience.